As the question says, a block A can slide on a frictionless incline of angle theta and length L kept inside an elevator going up with the uniform velocity v. Find the time taken by the block to slide down the length of the incline if it is released from the top of the incline. Now let us first draw the diagram for this question, in which we are having an elevator going up with a velocity of v equals to v and having a wedge kept inside it along with a block of mass m. Now notice over here that this velocity given over here is a uniform velocity. That is, the acceleration of this elevator is 0. So since there is no acceleration of this elevator, there is no pseudo force acting on this block, which implies that whether we put this wedge inside or outside the elevator, it will make no difference to it. So we can draw an equivalent diagram in which we are having a surface and a wedge has been kept over here along with a block of mass m and an angle theta of the wedge. We can mention the forces over here so that mg is shown in the downward direction. So obviously we will be having a component of magnitude mj sine theta in this direction. If we assume the acceleration a along the wedge in downward direction, we can frame the equation as mass into acceleration equals to total force in the direction of acceleration minus total force opposite to it. So cancelling out the mass factor, we get acceleration equals to g sine theta. Now we are having the acceleration, we have been given the distance covered, so we can easily employ the second equation of motion to find out the time in which it covers this distance. So S is equals to ut plus half a t square, where S is L, u is 0, so this becomes 0, half of g sine theta into t square, that is t square equals to 2L over g sine theta, or time equals to under root 2L over g sine theta. Now note in this question that we have taken the initial velocity u equals to 0 only because they have given a keyword released from the top. Since it has been released, we could take u equals to 0. Moreover, in such type of questions, take care to notice whether L has been given as the length of the distance which it has to cover, because sometimes they also give the height of the wedge as L. Then you will have to take the factor sine theta or cos theta as required over there. So don't forget to take care whether they have given the height or the length of the distance which block has to cover.